Good morning, everybody. My name is Jhoti Vasudev. I'm an engineer at Microsoft, and today I want to talk about something that's been a rage over the last 2 years. I'll give you a hint. It starts with A, ends with I. But I do want to set a little bit of context before that. In the 6th century, in India, the inventor of chess took the game to the local emperor. The emperor was so impressed, he promised the inventor any reward that he wanted. And the inventor made a seemingly modest request. He asked for grains of rice for the chessboard. 1 grain for the first square, double for next, and so on. As the days passed, the court watched in astonishment as the piles of rice grew exponentially. By the time they reached the final square, the amount of rice required was a staggering 18 quintillion grains, more than the empire had seen or could hope to acquire. That is the power of compounding. We build upon the work before us, and that is the cornerstone of progress. The difference between how far we get when our starting point is IBM's Deep Blue, square 15, versus when it is GPT-4, square 50, is enormous. And we have reached the second half of this chessboard. The site's not updated. I have a red line here, the site's not updated, never mind. that red line at the end of this chart marks the end of classical. Classical what? Tasks for women? No. That day will never come. We'll always have everybody's emotions to manage and everybody's schedules to manage. And no matter what goes wrong, where in the house, there's always going to be just one fall guy. All of that's unlikely to change. But we have reached the end of miniaturization of transistors. The smallest ones available now are 3 nanometers, about as wide as a human DNA strand. So compute is harder and harder to improve exactly when we need it the most for these gigantic models. In past, language models used to be like chinchillas, occasionally coming up with a coherent sentence or two. Fast forward to now, you're edging GPT-5. That's like going from tricycle to warp speed rocket. And the pace of innovation only seems to be accelerating. The company that I work for, our CEO often likes to say, there's no franchise value in our industry. We are all expected to innovate faster than we did in the previous quarter to show that we deserve to exist. But at the same time, it is evident that the traditional way of fitting in more transistors on an IC isn't really a viable way going forward. So where is the hope of keeping the pace of progress? We are technologists. We don't hope, we plan. And there have been promising developments up and down the value chain. Helion is working towards sustainable fusion-powered energy generation and has powerful backing from Sam Altman and Microsoft and many others. Extropic is a chip manufacturing startup that is harnessing the entropy in nature to power computations, entirely moving away from transistor-based approach. You've all heard of Figure 1, humanoid robot, which looks like space alien, things using OpenAI. And Devin, which is a full-stack software engineer and an autonomous agent. With everything changing so fast, how do we find where we fit in? As Emma Stone says in Poor Things, life is not about finding ourselves, but creating ourselves. And actually, George Bernard Shaw said it first. Emma Stone just copied it, like what I'm doing now. But we shape our own space by crafting how we build solutions. And today, I want to show you one such use case where a traditional manual rules-based process received a facelift using OpenAI and is now entirely autonomous. But I tell about any of this to my mom, she goes, all of that work is already done. All those smart people already built those foundational models, so where is your usefulness in this? I get to be the part of generation that is changing the face of life on Earth. I'm in for the ride. But there's something else. AI doesn't just magically read, mind, and solve problems. Someone needs to build it inside of the existing solutions to leverage the power that it offers. And so let's look at one such use case, because that is just what we're trying to do here. Picture this. You are browsing an app store looking for a meditation app. You stumble upon one, it looks nice, promising, great. You just want it on your device. But wait, there is one tiny hurdle. The dreaded address field. Why does a phone app need your address? No one knows. But you can't make a purchase until you put in your address. But you're too smart to give away your information so easily. So you concoct an address. My country is USA. What city am I in? Oh, I'm in the electronics office. Electronics is my city name. You put in some dummy values for state, postal code, and off you go. You hit that buy button like a boss. I'm not promoted to the system. But that one action has triggered a cosmic chain reaction, and now an unsuspecting tax professional is tasked with remitting tax on the sale that was just made to you. The problem of wrong addresses is not new. It has persisted for as far back as we know. The most usual reason for that is people sign up for trial accounts, which later get converted to paid accounts, but the dummy addresses persist. So we receive tens of thousands of unique incorrect address combinations every month. It does take a toll on the team. It requires many, many hours of manual work by people on the team to make those corrections, and it exposes the company to potential tax penalties if the manual corrections are not accurate enough, or if there are delays in remitting tax because of the human review latency that is introduced. This is the pre-OpenAI legacy address correction process that we used to follow. Each block is a separate manual step. Without going into the details, you can see it is pretty long-winded and time-consuming. To now, which is our new process powered by OpenAI and at a super duper high level. We take the incorrect addresses and some correction examples, make an API call to OpenAI, text DaVinci specifically, receive the response back from the language model, make another API call to USPS to acquire the master list to check the responses against, and depending upon the accuracy of the LLM result, we may make another call to the model. Receive the responses, compile them, parse them, append them back to the original file, and offload the file to them. We've used LangChain. LangChain is a prompt orchestration framework, and we really have to give it to them. They're punching above their weight here. They provide an easy-to-use, intuitive interface to build LLM applications. And so we provide a prompt with detailed instructions along with some correction examples. So maybe we can look at one of the correction examples here. Let's look at this third line from the bottom here. The wrong address that we received is USA, City of Canada, Colorado, and zip code. But the correct address in this instance should have been USA, Granada, which is an actual city in Colorado, CO, and then the accurate zip code. What we're saying with this example to OpenAI is that if you receive an address which is like this, the reasoning that you should follow to make corrections should be like that. And so we take the prompts and correction examples in conjunction with the actual question that we're asking it to solve, which is the incorrect address. And here's an instance of the usefulness of this approach. USA Electronics wrong address that we saw earlier. When we supplied to OpenAI with prompted examples, out come the correct state, city of bookings, and the zip code. OpenAI is smart enough to understand that electronics is not the name of a city, but a company. It looks up the address information for this company on the web, is able to parse the fields, populate the correct address attributes, and return the response back to us. Something like this cannot be achieved with the deterministic rules-based process. In context learning, this was so revolutionary. News media everywhere went, this changes everything. Technology companies now have to go back to the drawing board, as though we are usually huddled in our chairs waiting for the days to pass. No, we're always on the drawing board. In building this application, we've only utilized conversation-style prompting and have not fine-tuned the language model and not built RAG pipelines. So prompting is all of what it is. So we assign a persona to the model instance and give it some context. Then we provide a detailed set of instructions to it. So these are going to be things like prioritize postal code. In case of a conflict between state and city, retain the state, drop the city, and a bunch of other such rules per our experience and understanding of this data. Using strong, specific, positive, prominent keywords are likely to yield better results from the model per our observations, as opposed to saying, hey OpenAI, this is a wrong address, please see if you can make a correction and return the response back to me. The more assertive you are with the model, the better your result is likely to be. This technique of prompting with some examples is called few-shot prompting, which I'm sure you're familiar with. And these are a sample set of the results from this method. The leftmost table are the wrong addresses that we received from the source. The middle table are the corrected addresses using the legacy SQL-based process. And the rightmost table are the LLM-powered corrections. And we can look at any one example here, maybe the second one from the bottom. The wrong address that we received is USA, Palm Springs, Arizona, and a zip code. Palm Springs is not in Arizona, and that zip code does not exist. Legacy corrections understandably changed Palm Springs to a similar sounding city called Heat Springs, which is in Arizona, and found a postal code corresponding to Heat Springs. OpenAI, however, is smart enough to understand that postal code is a closer proxy for geographical location as compared to other address fields. So it takes the incorrect postal code, finds one which is closest geographically to the wrong postal code, and then finds a city name corresponding to that corrected postal code. What did they say? You don't rise to the occasion, you sink to the level of your training. Holds very true for the language models too. Those few-shot examples that we saw earlier are quintessential. The more representative they are of the kind of errors that we see in our addresses, the more accurate the corrections are likely to be. And we don't need too many. 12 to 15 examples kind of do the job. Onto the validation layer. Oh, I have a question for you. Why did LLM get nervous before its performance review? Because it was worried that it was being too biased in its self-assessment. Yeah, it was so sweet. Thank you for pretending it was funny. This is a relatively new solution area. There aren't too many out-of-the-box eval measures, so we took cue from other somewhat related GenAI solutions and built our own metrics. There are two levers here that we have to our disposal to tune the model performance: the prompt quality and the few-shot examples. And those are the two levers that we have tweaked in building this chart. So x-axis here is the number of few-shot examples that we provide with prompting. The green bars indicate prompts without detailed guidelines, and the orange bars, and my colors entirely changed on this as well. The orange bars here indicate prompts with detailed guidelines, so all of those detailed instructional rules that we provided to it. What this chart is saying is that the leftmost cluster of bars here show that with 0 few-shot examples and without detailed guidelines, OpenAI is able to return correct responses in 80% of the cases. But with detailed guidelines and 0 examples, it is able to return correct, accurate responses for 90% of the cases. The rightmost cluster of bars here show that with 12 few-shot examples and without detailed guidelines, we get correct responses from the model for 98% of the cases. But with 12 examples and detailed guidelines, OpenAI is able to hit correct responses for all 100 cases that we tested it with. So this also tells us that the examples that we provide to it are more important than the prompt itself. There are a bunch of other evaluation metrics. Responsible AI metrics are kind of built within Azure OpenAI such that it refuses to provide response to dubious questions. Also, we strip out any PII information before making an API call to OpenAI. So that score was rather easily 100%. Then there's the matter of the performance of the model itself. And there's only one real reference point here at our disposal to test it again, which is the time that people on the team take to perform the same task. And that, of course, isn't even comparable because there is very little perceptible time gap between when we ask a question to OpenAI and when we receive a response back. And then the number of model responses with malformed results. This is, after all, a non-deterministic language model. It will not take rules. Any rules that we provide to it are just guidelines. So we do receive truncated responses once every 5,000 calls. No wonder everybody doesn't just love the idea of switching all of their processes onto GenAI. It will hallucinate. But the wrapper that we have built around OpenAI call is able to handle those instances. As a result of doing this, we realized some easy wins. The team saved a whole bunch of hours every month because it's all end-to-end automated now. The data is available faster. The human review latency factor is kind of taken out. The process is consolidated. The model is generalized enough to understand the characteristics of different types of failures, adverse failures that we receive across different sources with the endless context that it has from the web. So just one process to solve them all. And then it is scalable, again for the same reason. So all of that. There are a bunch of other use cases I've just shared with you. You guys have access to these slides through this podium. As we journey towards the future, I see us not just as participants, but as stewards. We're the ones making sure that AI doesn't just mimic us, but works with us. Yes, we're approaching ASI, but this is the time when we can ensure that it's all going in the right direction. And you, with your unique skill sets and experiences, are perfectly positioned in terms of time and place to shape the adoption of AI, leveraging your experiences and crafting solutions that address your distinct challenges. This is an unusual time. In my experience, says that learning from one another and building upon each other's work is likely to take us further and faster. This was my first time at WIDS. I've had the greatest time at the conference so far. I'm thrilled to be among you all, and I can't wait to learn more about each one of you. I'd love to stay connected on LinkedIn if you have me. And with that, we can open for our questions.
I get to say, okay. Yeah, thank you so much for your talk. I work in platform health, so I'm geeking out over it. It's really great. I was wondering, how did you deal with the solutions? You mentioned the wrappers, so I can talk more about that, as well as did you adjust the temperature model to these solutions as well? First part of the question. Second part, for prompt engineering, you shared what went really well with the positive attributes and then also design the role. What were some of the things that were when you were designing the prompts?
Yeah. So the temperature, we experimented with a whole range of temperatures, starting from 0.3 all the way to 0.9. But my experience said that the ideal performance is around 0.7, where it's creative enough, but it's not appending the country of Bulgaria to city of Redmond. So 0.6 to 0.7 work best. The wrapper that we built is very specific and unique to our application. There are just to specific data sources. So OpenAI call is like 6 lines of coding, but the entire wrapper is more like 900 lines.
Okay.
So it was pretty elaborate. And then the second part of the question is that with the prompting. Again, the prompt that I showed to you guys is after a whole bunch of trial and error. It was great first time to do it. It started with like 2 lines of prompting. And what I shared with you is exactly what I asked it. That this is my wrong address, can you find a way to correct it? And it did return correct responses reasonably good number of times, like 80 cases out of 100. But then it's those corner edge cases that we're always really solving for. 80-20 of the time is spent on solving those 20% of the edge cases. And so just trying a whole bunch of different text combinations resulted in that final output, which seemed to yield ideas.
Awesome. This is really impressive. Thank you so much.
Thank you.
Yeah.
Yes.
How did you determine what the correct responses were? Because it doesn't
That
seem like
is-
there's necessarily enough information to
Oh, I love
determine
it. That's
the
a
truth.
good question. Yes, yes. So the first criteria is it needs to match to the USPS master list, which is everything that is correct. But then while testing, we get 150 different data attributes, and these address attributes are just 4. There are other fields that help us ascertain if the response that we have received aligns with those. So these are, for example, ship to addresses. We also have sold to addresses, which in many cases would match. But more importantly, we have a tax area ID field if you are anywhere within the tax world. This is like a unique number at a greater granularity than postal code. So the address that we receive needs to match with that tax area ID. While testing, those are the things that we look for to make sure that what we're getting is actually accurate and not something that we just want to see. Yes.
A tag on to that question. So they do have human in the loop to do this validation ever for the test cases.
100%. Yes, we tested. It took what, 4 weeks to build, and it took 5 months to test, because how else would you do it? Language model is telling you something, there is some way that you need to. So for 5 months or 6 months, we compared the legacy process with the language model corrections, and then understood the differences, and came with the metrics why this is superior as compared to code.
Specifically, when you are moving this towards the business, how much pushback would you get in terms of the incorrectly classified addresses passing through, and how do you, I guess, communicate and mitigate that as developers creating a product that is still prone to error?
That's a great question. However, in this instance, we were the final user, along with some of our stakeholders, and everybody was, besides themselves, to be saving time and not having to spend hundreds of hours, doing these corrections manually. But there are instances wherein you build something, you're very proud of it, and you aren't entirely sure how to sell it to the stakeholders, to the business, because you are the ones benefiting from all of the efficiency, and it really means nothing for them. In fact, it costs them time to test whether or not this is good enough for them. So, yeah, but thankfully we didn't have to deal with it in this instance.
So this is replacing a lot of manual hours. How do you sell it to the end users that you're not replacing their jobs?
Also very good question.
Oh.
You know what happened? Just around the time that we were building it, Microsoft is expanding left and right because of all the new products that we're launching. And in this instance, there was really just no shortage of work. In fact, we weren't being given enough resources, but the amount of work that was coming our way was just ever increasing, like it always did. And so in this instance, again, our team was very thankful, because now they don't have to spend 14 hours doing office work. So sometimes saved, but then they take care of the rest of that during this time. But what you're asking is a very, very valid question. Until it comes top down, becomes formalized, or we get to a 3-day work week kind of a setup, that's always a question that we're going to have to tackle with it. This is replacing people's jobs.